Hi everyone. So before, we used synthetic division to divide this top polynomial, which I'll call f of x, by this bottom polynomial, x plus 3, that's x minus k, where k is negative 3. That's the number we put in the dunk tank. And we got this right-hand side over here. So we claim that the left side, this fraction, is equivalent to this over here. Let's actually try this out on Desmos. Let's see if Desmos agrees with this. All right, so on the left side, y equals the quantity 2x cubed minus 3x plus 5 all over x plus 3. All right, so we got that over there. Let's see, on the right side, y equals 2x squared minus 6x plus 15 minus 40 over x plus 3. And it looks like we match up. How do you like that? Again, not a proof, but pretty convincing. So it looks like the left side is equivalent to the right side, visually. Now, what's another thing we can do with this statement? Well, we can also write the corresponding division algorithm form. The division algorithm form. That's where we multiply both sides by the divisor, x plus 3. So we're going to multiply both sides by x plus 3. I'll do this in purple or blue. Multiply by x plus 3 on the left. And multiply by x plus 3, all of this. Multiply all of that by x plus 3 on the right. So on the left here, the x plus 3's go bye-bye, and you're left with that numerator, f of x, right? You're left with f of x over here, equals all this times x plus 3. So what happens is you get f of x, the numerator, 2x cubed minus 3x plus 5, equals, I'll put the x plus 3 in front here, times this polynomial, quotient, the quantity 2x squared minus 6x plus 15, minus, and then when you multiply the fraction by its own bottom, you get the top, 40. Just like if you take 2/7 and you multiply by 7, you end up with 2. Okay, likewise here, when you multiply the fraction by its own bottom, you get the top, 40 with a minus in front. That's the division algorithm form. And why is this interesting? All right, now my claim is that the left side is equivalent to the right side, even if x equals negative 3. Now, some of you might object and go, well, wait a minute, negative 3 was not in the domain for this fraction or this fraction. Don't worry. By a calculus limit argument, I claim that the left polynomial is equivalent to the right polynomial, even if x is negative 3. In fact, negative 3 is the number I want to plug in. So here's my claim. If you plug in x equals negative 3 on the left, what is that? If this thing is f of x, I'm talking about evaluating f of negative 3. What happens when you plug in negative 3 on the left-hand side? You're evaluating f of negative 3. Equals, well, if you plug in negative 3 into here, x plus 3, negative 3 plus 3, guess what? That's 0. And therefore, this times this, 0 times all that, this whole thing is going to be 0. So if you plug negative 3 into the right side here, this whole product over here drops out, and we're left with this constant term, this remainder, the negative 40. So let me repeat what I just did. The problem value for x here, which was negative 3, that was k, right? K was negative 3. It was the problem value for x down there. If you plug in the problem value for x, that is k, or negative 3, on the left side, this is f of k then. We're basically evaluating f of k. How can you evaluate f of k? Well, this drops out, and it's just the remainder. f of k equals the remainder r. F of k equals r. That is the remainder theorem. In a way, it's one of the shortest conclusions in the whole of pre-calculus. Bottom line, f of k equals r. If you plug the guy in the dunk tank, the problem value for x up here, into the numerator, right? This numerator guy, that's f of x. F of k equals the remainder. So, if I ask you the following, what's the deal? If you have f of x equals 2x cubed minus 3x plus 5, what is f of negative 3? Now, of course, you could plug negative 3 into your calculator, but a lot of people would make a mistake because a lot of people have trouble plugging in negative values, and you have a cube and all that. So a lot of people would mess this up, actually, even on their calculators. But there's an alternative. You can use synthetic division. You can use synthetic division to evaluate functions. Namely, at x equals k. F of x equals ya. You want to know what f of negative 3 is. What can you do? Well, you do the synthetic division. You plug negative 3 into the dunk tank, all right, work out the synthetic division, and this remainder here is the answer, negative 40. So I claim that f of negative 3 is negative 40. If f of x is the numerator, the dividend, f of this, f of k equals this, r. F of k equals r. F of negative 3 equals negative 40. Right. So there are two reasons why you would want to make this table. One, if you wanted to evaluate f of negative 3, where this was f of x, or if you wanted to divide f of x by x minus k. Now remember, if you're dividing f of x by x plus 3, there's a sign flip. If you're dividing x by x plus 3, remember there's a sign flip, and you actually want to put k equals negative 3 in the dunk tank, like so. So if you're dividing by x plus 3, there's a sign flip, you put negative 3 in the dunk tank. But if you're evaluating f of negative 3, there's no sign flip. Do not flip the sign. There's no sign flip if you're evaluating a function. All right. Now, where do you evaluate functions? Anytime you want a y-coordinate. So for example, let's go over to Desmos over here. All right. Let's go to a new screen here for Desmos. All right. Now let's look at y equals the numerator, the dividend. So let's consider, the graph of y equals 2x cubed minus 3x plus 5. It's this snake. Let's say that I care about when x is negative 3. I want to know the intersection point between these two graphs, the red and the blue. Okay, now it might help if I change the window. All right, so let's make the x go from negative 5 to 5. All right. Okay, so unequal scales, that's okay. Well, actually, it works out very nicely. You can tell right now it's going to be negative 3, comma, look at this, negative 40. So I want to know the point on this red graph that has x coordinate negative 3. What's the function value at negative 3? What's the y coordinate? F of negative 3 is, lo and behold, negative 40. That's the y coordinate of this point. So you might actually want to play this game in calculus. For example, what if you have a max point up here? Let's say you know its x coordinate is negative 3. You can use synthetic division and find the y coordinate. You can use, in fact, when I taught calculus, students would do this. They'd use synthetic division to find y coordinates. It's very convenient. And you can use synthetic division. For a lot of people, for a lot of people, the synthetic division is faster than if you were to actually plug into a calculator. This is faster and more accurate than if you were to plug into a calculator. Because with this, it's just bring down, multiply, add, multiply, add, multiply, add. That's more straightforward and more accurate and harder to mess up for a lot of people compared to if you tried to take this guy and plug in -3 on a calculator. A lot of people would mess that up. Next up, how is this all related to polynomial theory? Zeros, factoring, and division. Next time.